For decades, the concept of energy weapons has resided largely in the realm of science fiction. Visions of laser blasts and particle beams have fueled our imaginations. Today, however, these technologies are moving rapidly from speculation to operational reality within advanced military programs. The United States has long been at the forefront of defense innovation. Buried deep within classified projects and black budgets, research into directed energy weapons, or DEWs, represents a profound shift in military capabilities. These systems promise to reshape the very nature of conflict. The theoretical groundwork for energy weapons dates back to the mid-20th century. Scientists during the Cold War explored concepts of death rays and sonic cannons. Early experiments were often crude, but laid crucial foundations for future breakthroughs in physics and engineering. Initial efforts focused on understanding how energy could be concentrated and projected over distance. Limitations in power generation and beam propagation were significant hurdles. Yet, the strategic implications of such weapons kept research programs alive, often under extreme secrecy. Today, directed energy weapons are broadly categorized into several types. High-energy lasers, or HELs, are perhaps the most widely recognized. These systems focus intense beams of light to heat, burn, or ablate targets, offering precision and speed unmatched by conventional munitions. Another critical component is high-power microwave, or HPM, technology. These weapons emit electromagnetic pulses capable of disrupting or damaging electronic systems. The active denial system, for example, uses millimeter waves for non-lethal crowd control, causing an unbearable heating sensation. The primary allure of DEWs lies in their precision and speed of light engagement. Lasers can intercept incoming missiles, drones, and artillery shells with incredible accuracy and at a fraction of the cost of traditional interceptors. This defensive capability is a game changer for protecting critical assets. Offensively, DEWs offer new options for surgical strikes and non-lethal incapacitation. They can disable vehicles, communications, and power grids without causing collateral damage or loss of life, in the same way kinetic weapons might. This offers commanders unprecedented flexibility in escalating conflict. Developing effective energy weapons presents immense technical challenges. Generating sufficient power to sustain a high-energy beam requires advanced power sources and thermal management systems. The size and weight of these components remain a significant barrier to widespread deployment. Atmospheric effects, such as turbulence and absorption, can degrade beam quality over long distances. Adaptive optics and advanced atmospheric compensation systems are crucial for maintaining lethality. Miniaturization for deployment on tactical platforms is an ongoing engineering priority. While acknowledged DEWs are impressive, there is persistent speculation about even more advanced classified systems. Reports from various sources, including former military personnel and whistleblowers, hint at technologies far beyond public understanding. These remain shrouded in deep secrecy. Some theories point to exotic propulsion systems derived from energy manipulation. Others suggest weapons that exploit fundamental forces of physics in ways currently deemed theoretical. The line between advanced science and classified programs often blur in these discussions. One particularly persistent area of speculation involves electrogravitic or anti-gravity technologies. Proponents claim that certain classified projects are exploring methods to manipulate gravity using high-energy electromagnetic fields. These concepts derive from obscure physics and anecdotal accounts. If such systems exist, their implications are staggering. They could revolutionize propulsion, enabling unprecedented speeds and maneuverability. They could also form the basis for entirely new classes of energy weapons, perhaps capable of kinetic manipulation or localized energy fields. Much of the advanced energy weapon research takes place within what are known as black projects. These are highly classified programs with restricted access and often undisclosed funding. Their existence is sometimes acknowledged, but their specifics remain deeply hidden from public and congressional oversight. The motivations for such secrecy are multifaceted. Protecting technological advantages from adversaries is paramount. Preventing the proliferation of dangerous new weapon systems is another. Yet, this opacity also fuels much of the speculation and conspiracy theories surrounding these developments. The advent of highly advanced energy weapons raises profound ethical and geopolitical questions. The ability to disable or destroy targets with unparalleled precision and speed could fundamentally alter the nature of warfare. This could lower the threshold for conflict, given reduced risks to personnel. The development of these systems could trigger a new arms race among global powers. Defining international norms and treaties for these weapons will be incredibly challenging. The potential for misuse, accidental deployment, or escalation demands careful consideration and transparent discourse. As the United States continues to invest heavily in these secret technologies, the future battlefield will likely look dramatically different. Energy weapons promise to provide decisive advantages, from impenetrable defense to surgical offensive capabilities. The age of kinetic dominance may be drawing to a close. The journey into the unseen arsenal is far from over. As scientists push the boundaries of physics and engineering, even more astonishing capabilities may emerge from the shadows. The invisible arsenal continues to evolve, promising both unprecedented power and profound challenges for humanity.